So, welcome everyone to the sixth lecture of Intro to Android Development. Um, Glad you're still with us. This week, we're starting off with announcements. So, the final project starts this week. Guidelines will be on our website, and um, you'll have 2 weeks to do it. Best of luck. Uh, no, Drew, you'll have a fairly long time to do it. Best of luck. So, homework 5 will be due tonight at midnight, and homework 4 grades will be posted soon. That's all we have for announcements. Let's get into the networking. So, networking. Android is an OS for phones. Phones are uniquely a networked device. In fact, they kind of don't operate without a network. And as such, most of the apps on them are quite useless without the internet. And it's a critical part for most apps, but also the most unreliable. Um, so today we're going to be talking about permissions, async tasks, and HTTP. So you got a few lines that you have to put into the manifest before you access the internet. Now, these are mostly legacy handovers. More recent versions of Android kind of expect that your apps can go online. So you can just put these in the manifest, and you don't have to add any extra request permissions that will check if they have internet access. It will pretty much hand you internet access if they have internet. No box will pop up, no nothing like that. So you cannot network on the main thread. The main thread is what runs the UI, what runs all the fancy parts of the app, and you are not allowed to do any networking on it because networking is a delay. Networking will wait for something else to happen. And if you click the refresh button on an app and it hangs, completely freezes, everything else locks up, until the networking's done, you will have a lot of very unhappy users very quickly. As such, Android includes a separate class to execute these tasks that's called Async Task, quite literally an asynchronous task. To set up a basic constructor that sets up what you need, often you send it in a callback, so that you can receive the um, information after it's done completing a task. And then set up some overridable methods. So let's get into an example of one. Here is a class for going into a URL and grabbing a string of data from the website and then storing it, or returning it, really. So you'll notice that there is a public constructor up top that takes in a callback to do something after it's done. Um, and then after that, you have a protected overridable function called do in background. This is exactly what it sounds like. It will execute the task you wanted in the background without interrupting the main task, the main thread. And so in this case, it will do all the networking stuff in the background. If you put any of these things that require a networking or background task in the main method, your app will not build. It will not let you. Um, Similarly, there's an on post execute that will happen after your request is complete, after this background task completes itself. So this is often used to handle the refreshing of the UI, the changes associated with whatever has now happened in the background. There is a method for run on the UI thread, so you can put that in there to run a task on the UI thread after you have executed something, or initiate a callback to a method in the main activity that can handle such. In addition, so to execute this async task, all you have to do is write JSON thread, retrieve weather data, let's say if you're getting it from like a weather API, and then just give it the callback you wanted, and then execute the background task. There are also a few other methods in async task, like on pre-execute and on progress update, and on canceled, that also do different things. On pre-execute, you might want to show up that little loading modal during a you might want to put that up before the network request happens so it can spin during that. On progress update, you might have a background task that can update you on the progress of how it's gone, like say an upload. And that can give the user feedback as well on how far the background task has completed. You also have things like on canceled for if the network task was canceled in the middle of it and then whatever happens next. These are all parts of the built-in async task in Android and all become very helpful if you want to do some simple networking. And not everyone actually knows all the details of networking and such, so I shall go over a bit of general HTTP. HTTP has several request types that you'll find. Get for data retrieval. If you're getting information from a website, this is the first thing that happens. This is where the HTML will download and whatnot. And then if you hit an endpoint with a GET request, you'll get the data that you requested. Post is similar. You send a block of data to whatever HTTP endpoint you want. Unlike, so GET shouldn't have anything besides a request. Post shouldn't ask for, Post will send a request and expect to get a bunch of things, and expect to not get too much back. So you send a block of data through Post. You have more obscure ones that aren't used as often, like put. Put is telling the server to save this thing. It's like post, save this thing there. However, unlike post, put should only happen, will tell it to save it there and overwrite whatever was there. So a put request is supposed to, if you send multiple put requests, there should only be one thing at the end. It should act as if only the last put was set there. Compared to post, in which case, post should have 3 items there in the database now. Delete is self-explanatory. You also have things like head, phrase, options, connect, patch. These are all in the HTTP spec. However, if your backend engineers tell you to use one of these, feel free to just throw the GitHub database up. Don't bother. Request structure. A request for an HTTP request has a header, which has information about it, if it's a GET, if it's a POST, whatnot, as well as some metadata about it, like time, authentication tokens, if you want to authenticate the user, etc. You also have other things in the body that contain the actual content of the request. And then the server should respond accordingly when the request is received, and then the server will send something back. The server's response to a GET request will often return the requested info. The response to a POST request, however, would be like a confirmation of proper handling. Say, I got the response, it's now in the database, here's a success. And speaking of such, HTTP also has different status tokens that will tell you more about what HTTP, what the request has done. So if you get back a 200, which is what you would most commonly get back, 200 means okay, got it. I have done what you've asked and it has successfully gone through. 100 has informational responses such as continue and similar, where, or connect, where essentially it's telling you, yeah, got that, still working on it. 300 responses are redirects. 400 is where you get your client errors, your 404s, your 403 forbiddens. These are telling you that as the client, you have done something wrong. A 500 error is a server error, where the server has gone wrong somewhere, and it has screwed up in some way. Therefore, the easiest way to remember these status codes is as follows. Yep, now you'll never forget them. So, there are some networking libraries that will make all this easier. We at AppDev often use OKHTTP by Square. They make a very nice networking library that handles a lot of the asynchronous stuff, a lot of the error handling, and a lot of putting the data that you've gotten back into the right places. There's also a similarly popular one called Retrofit, also by Square. And then if you look up Android Networking Library, the first one that comes up will be the Fast Android Networking Library by Amit Thekar, which is also built atop OKTTP. So if Square falls out of the small business options, they have apparently the Android networking sector to go into because they have a monopoly there. Well, not really. There are other options such as Ion and Android Async by Post, I believe, which are also often used. However, the most popular by far is Square's OKHTTP, and that's what Leslie will be showing you today in the demo. So, enjoy that.
Hi guys, today I'm going to be giving a very simple demo on how to do networking in Android. The two libraries that we are going to be using is OKHTTP and Mocchi. These two libraries are third-party libraries made by Square, but they are very popular libraries in the Android community, so you'll find a lot of resources about them. Obviously, you can use any libraries that you want for networking, but we felt that these two libraries are really simple to use and also really easy to understand. So your first step in terms of doing networking is that you have to import these two libraries in the build.gradle, and you can easily find import statements on the Square website. And then you want to find the public API that you want to use. In our case, we're going to use the API from New York Times. And for most APIs, you have to make a website on the developer console. And this is so that you can tie your app to the API key. So in our case, we'll create a new app. Let's just call it Lecture 5 Demo. And then we just want to enable the Top Stories API. And then we can create it. So that was actually really simple. For a lot of APIs, like the Spotify API or like Google Maps, they will ask you for a SHA-1 fingerprint. This is just an extra layer protection that helps connect your app to the API. And so if they ask you for a SHA-1 fingerprint, this means that if other people get access to your API key, they can't use your app because they won't have the same fingerprint as you do. So to generate the fingerprint, you would just go to Gradle on the side, and then you would just click into Tabs, Android, and then Sighting Report. And if you click that, you'll see that a SHA-1 fingerprint was generated for you. And this is unique to your console. So this helps protect other people from using your API keys. And this is also really important if you have several developers working on a single app that uses the same API key. You'll need to register everyone SHA-1 fingerprint. Okay, so now that we generated our API, you'll see that there is a key and there's a secret. So the only one we have to worry about is the key. The secret is a secret key that is used for encrypting your message, either on the API side or on the local side. But we never want to, I guess, like copy this key into our public repo, especially if it's open source. So normally we don't have to worry about it. Let's just copy the regular key, and then we can put it into our app. Generally, you also don't want to just have your key out in plain text, like here. You generally want to protect it through other types of files. But if just for this course and also for this demo, to keep it simple, we're just going to have it inside the app. And then let's just create our HTTP client. So let's do HTTP client. And then we can generate our URL. So let's look into documentation. So in terms of top stories, it's really nice that they give you an example call. So you see here that there is the base URL, and then there is the query that comes after it. So we just need a base URL for now. And then generally when you have a URL, anything that comes after a question mark are queries. This may be something like they may ask you for your search query or for certain IDs. But in our case, they just want the API key. So we can just do URL builder.add query parameter. And then we just insert ID. And then we can just generate our URL. And now we want to make our request object. New request builder. And then now we want to make our client make a new call using our request. And so this basically puts a request on the background thread, and nothing will happen until the request returns something. So you'll see that when we create a new callback, there's two methods that we have to override. One is on failure and one is on response. So on failure is called when nothing is returned. So this could be that your request maybe timed out, or maybe your app crashed before the request finished. So that'll be on failure. And we just want to print out an error message that happens. So on response is called when something is returned, but that doesn't mean that your returned object is successful. In this case, we want to check to see if the object is successful. Response is successful. And if it's not successful, we just want to throw an error. Expected code. And if it is successful, we just want to print out what it is for now. Testing response body string. Okay, so let's run this. And actually, let's test it right now by changing this key to something else. Oh, it's still the setting report. Oh, so you see that we get an error. The error is permission denied, no internet. Oh, turns out I forgot to uncomment this. So this is actually a really common error that I personally make because I often forget that a permission we have to give our app is the internet because obviously we can't just randomly use users' internet. Okay, let's run it again. Let's see what happens. App again. Okay, so you see here that the app doesn't crash. Our OK HTTP request is unauthorized. So you'll see here that even though we have an error, the app doesn't crash. And this is the ideal behavior for your app. You want to do a lot of catches for errors, and you want to handle the error on the code side so that the app doesn't crash. The worst thing that you can do for the user is to have the app crash on them. You rather have it be handled either through a UI element, you can say like no internet or like wrong user, but you just don't want the app to crash. So in our case, the key is wrong. So let's just change it back to the original ID. And hopefully this gives us no errors. Nice. So we do testing. We can see that it gives us, oh, I spelled it. We can see that it gives us a nice JSON string. And if I were to put it and format it, it would look something like this. And so you can see it gives you status, it's okay. It gives you the result. And then it gives you all of this for your JSON. It's pretty good. Now we want to actually, so we get this JSON. We're basically at the same step as when we were making our eatery demo app. We want to turn this JSON into Java objects and data. And we could do that by parsing the JSON. As you remember from the previous demo and also from your homework, it's really tedious to parse everything just by hand. So that is where Mocchi comes in. Mocchi is a library that helps you parse JSON into Java objects, and it's actually really simple. So let's go back to our JSON. The only thing that I want personally is the title and the abstract. Yeah, everything else I don't necessarily need for this demo. So they're just two objects. Okay, so I'll just create a very simple model. And I'll call it article. And I'll just have two things. It'll have a title, and then it'll have a abstract. So you want your variable names to match the names inside the JSON file, and so that way the Mocchi library will know what data to actually pull out. But in our case, you'll notice that gives us an error because abstract is actually a keyword in Android. So we can't actually use that as a variable name. So let's just change it to summary. And then we want to let the library know that this is actually abstract inside the JSON file. So we'll just do a quick JSON. And then we can do name equals to abstract. And this tool is really nice because if your JSON has like really weird keys where it has like spaces in it or weird symbols, you can just use this line to help you translate it into what you actually want. So that's an article, but you'll notice here that everything's nested in something called results, and results is basically a list of articles. So let's just create another model. And then we'll just call it results. And it'll just contain a list of articles. Article results. Okay. That looks good. So in our case, we just want to comment this out. Now we just want to create our Mocchi object inside the else. So this is assuming that everything's a success. So Mocchi equals to new Mocchi.builder. You'll notice that syntax is very similar to OK HTTP build. And then we want to create our JSON adapter. And then the highest level object that we need is called result equals adapter. And then we just want to put in our class result. And then we can pull the data from our adapter equals to JSON adapter from JSON. And then we'll just create our array list article. Results. Okay. For the sake of keeping this demo short, I actually created a lot of different files ahead of time. Basically, in our main activity, we have a simple list view that I already created. And for our list view, I actually want to make a custom list view where it has two text views. You can see it has the name and the abstract. I also created it here. And then that means that we also have to specify a custom adapter because we're not using a layout that's already pre-made by Android. Inside our custom adapter, we're using the array adapter, but instead of string, it's actually going to take in an article. And let me comment this. So this should also be article. You'll notice here that the syntax for this custom adapter is very similar to what we created for the recycler view demo. So you would need a constructor. It takes in a context, a resource ID, and then your data. You'll notice that the resource ID is 0. It honestly doesn't matter what the resource is here because we're going to override it anyways. And we actually override it inside getView. Basically, we retrieve our article object. We check to see if the view is null. The view may not be null because you may be reusing a view that you already created. So in that case, you don't want to recreate it. Otherwise, you'll inflate the layout. And then we've seen this before. We'll just find view by ID and we'll just set the text. So it's actually very simple, this custom adapter. And then inside body, we have our data. And let's see what happens. We actually just print it out. The testing body toString. Okay, you can see it prints out a list of articles. That's not that useful, but at least we know it works. So now we want to update the UI. And to update the UI, we actually have to hop on to a different thread because the UI operates on a different thread than the background. So we want to just call run on UI3 and create a new runnable object. Okay, and we just override run. So inside the run method is where we actually update our UI. Dispute object actually. Dispute LV. We also want to create our custom adapter object. So CA do custom and custom LV equals to find view by ID main LV. We just want to create our custom adapter equals to new custom adapter. It needs a context, and you'll notice that we type in this, it will give us an error, I think. Body. So it gives us an error because we're inside our we're inside a new function and we're not inside on create anymore. We can't call this, but we can call get ApplicationContext. Now get us the context. Nice. Well, and then let's feed this adapter into our ListView and custom. And then let's see what happens. Nice, and you'll see that it updated with everything from our JSON. I guess there's a lot about coronavirus right now on the top stories. Yeah, and that's sort of a simple way to transform your JSON into Java objects really easily. I won't be showing you how to make a post request, but basically in a post request, instead of pulling data from an API, you'll be sending it. I think with the Times API, we can't make any post requests. But for your final project and anytime in the future, if you decide to use OK HTTP, they have this really nice page called recipes, and they basically have a lot of template code that you can use to help you code the networking part. And so you can do asynchronous get, which is what we did. You can get access headers, and then they go into posting. This is where you can send data back to the API. And so this is actually really nice. And then for the most part, it kind of covers what you need. For Mocchi, I only did the most basic part of Mocchi where it auto creates the objects for you. But this GitHub page is actually really nice because it gives you a lot of options and a lot of flexibility in terms of what you want to do. The most important thing I think here, or the most important feature I think that Mocchi has, is the from and to JSON methods. So currently in our app, you'll notice that it kind of auto generates the objects for you, and we just take in whatever the JSON gives us. But in the event that the API is not that great and you don't like the data coming in from the JSON, you can actually modify the data before it even enters your objects here. You just want to make sure that when you modify it from the JSON, you have to do the reverse inside to JSON so that in the event, in the possibility that you may want to post, it auto transforms your Java objects back into the JSON that's supposed to be in. And this is really useful for like dates, for strings. If you want to use enums, you can transform it to what you want inside your code base. And Mocchi is really nice because you can check for null and like sterilization, so that's really nice. And there's a lot of other features that Mocchi has. But overall, it's pretty flexible and it's really similar to JSON. So if you're used to using JSON, Mocchi should be very simple. Or you can also use JSON. That's fine too. But yeah, this is a very basic demo of networking on Android. Hopefully you find this useful and that you'll be using these two libraries inside your final project.